Hello everyone, my name is Shubham Singh and in this session we are going to discuss some concepts of mensuration and questions related to it. Let's look at some of its questions. So first question says, a 5 centimeter cube is cut into as many 1 centimeter cubes as possible. What is the ratio of the surface area of the larger cube to that of the sum of the surface area of the smaller cube? So I have one cube which is of 5 centimeter. So one cube is there. So surface area of any cube is given by 6 of side square. Now side for this cube is given to me as 5 centimeter. So 6 into 5 square, which comes out to be 50 centimeter square. So this is the surface area of the larger cube. Now it is being cut into smaller cubes of 1 centimeter. So for this cube, this is of 1 centimeter. Now surface area of this cube is 6 into side square, which is again 1 square, that is 6. Now in all, how many cubes are there? In all, I have 125 cubes, smaller cubes. So surface area of all these cubes will be 125 into 6, which is nothing but 750. Now the question is asking the surface area of the larger cube to the sum of the surface areas of the smaller cube. So surface area of the larger cube is 150. Surface area of the smaller cubes is 750. So ratio comes out to be 1:5. So our answer to this question is 1:5. Let's look at the solution to this question. Moving on to the next question. A conical cavity is drilled into a circular cylinder of 15 centimeter height and 16 centimeter base diameter. The height and base diameter of the cone is same as those of cylinder. Determine total surface area of the remaining solid. So the question is saying this complete cylinder was there initially. Now diameter of the base is given to us as 16. So radius will become 8. Height of the cylinder is given to us as 15. Now if height is given to me, I need to find the slant height. So slant height is nothing but L is root of 8 square plus 15 square, which is 64 plus 2 to 5. This comes out to be root of 289. So slant height comes out to be 17. Now I need to find the total surface area of the remaining solid. Now total surface area of this figure includes CSA of cylinder plus CSA of cone plus areas of base. CSA of cylinder is nothing but 2 pi RH. CSA of cone is nothing but pi RL, and area of base is pi r square. Now I need to solve this value. So pi is out here, it's common. 2 into r into h plus r into L plus r square. This value will become pi 2 into r into h is 15. R into L is nothing but 8 into 17 plus r square is 8 into 8. This value comes out to be pi 15 8s are 120. 120 into 2 is 240. Now 17 8s are is 136, and lastly 8 square means 64. This value comes out to be 440 pi. So our answer to this question is 440 pi. Let's look at the solution to this question. Moving on to the next question. The figure below shows two concentric circles with center O. PQRS is a square inscribed in the outer circle. It also circumscribes the inner circle, touching it at points B, C, D and A. What is the ratio of the perimeter of the outer circle to that of the polygon ABCD? So I assume the radius of this inner circle to be R. Now this is making a right angle triangle. If this is R, this will become root 2R, and this is also R. So I can say this is root 2R. Now if I draw this line, this value will become half. So this value will become R by root 2. This angle is nothing but 45 degree. Now if I assume this value to be H, I need to find sine theta. So I have this triangle which is as 45 R upon root 2 and H. Now sine theta is nothing but P upon H, which is perpendicular upon hypotenuse. Now this value will become sine 45 is equals to P R upon root 2 upon h. Sine 45 is 1 upon root 2. Now this h will become r by root 2 into root 2. So h is equals to r. Now this whole side will become h and h. So complete side. So side of PQRS will become 2h is equals to 2r. Now I need to find the diameter of the circle, larger circle. Then again I need to find diagonal. So diagonal d square is nothing but 2r square plus 2r square, which will become 4r square plus 4r square. D square will become 8r square. D becomes 2 root 2 of r. Now if I need to find the radius, then r will become root 2 of r. My radius is root 2 of r. Now the question is asking what is the ratio of the perimeter of the outer circle. So perimeter is nothing but 2 pi capital R, which is 2 pi into root 2 times of r, and to that of polygon ABCD, So ABCD is nothing but square only. So perimeter of square is upon 4a. This will become 2 pi into root 2 of r into 4 into a. A for this case is root 2r. So again root 2r. This root 2 and root 2 get cancelled. R get cancelled. The value will become pi by 2, or I can say the ratio is pi is to 2. So our answer to this question is pi is to 2. Let's look at the solution to this question. Moving on to the next question. A sphere of radius r is cut by a plane at a distance of h from its center, thereby breaking the sphere into two different pieces. The cumulative surface area of these two pieces is 25% more than that of the sphere. What is the value of h? So for this question, let us assume a sphere having the center as O. Now I assume the radius of this circle to be r. Now this sphere is cut by a plane at a distance of point h. So this value is nothing but h. This value is again I'm having as r. Now the surface area of this sphere is given by 4 pi. Surface area is given by 4 pi r square, and the cumulative surface area of two pieces 25 more than that of the sphere. So cumulative of these two spheres will be given to me as 25% more, 25% more, which means 4 pi r square plus 25 by 100 into pi r square. This will become 5 pi r square. So cumulative surface area of these spheres is 5 pi r square. Now the difference between the original and the new surface area comes out to be 5 pi r square minus 4 pi r square, which is equal to pi r square. Now this is the difference between the original and the new spheres. So I assume that the new surface area is divided equally in both these spheres. So pi r square by 2 for any of the sphere newly formed. I'll assume the radius of this sphere to be r1. Now the question is asking what is the value of h. If you closely observe, r1 is the radius of this sphere. This is nothing but r, and h is the height. You can see that these three are forming a right angle triangle. Pi r1 square is nothing but pi r square by 2. This will become r1 is equals to r by root 2. Now according to right angle triangle, r square is nothing but h square plus r1 square. So r square is r square, h square plus r1 square is nothing but r by root 2 whole square. This value becomes r square is equals to h square plus r square by 2. R square by 2 is equals to h square. The value of h comes out to be h is equals to r upon root 2. So our answer to this question is h is equals to r upon root 2. Let's look at the solution to this question. Moving on to the next question. In the figure given below, MN and NL are the adjacent sides of a square, and the arc MPL is drawn with N as center and MN as radius. P is a point on the arc and PQR is a square such that RS if extended passes through L while RQ if extended passes through M. What is the ratio of the area of the square of the side MN and the square PQRS? Now the question is saying if RS is extended, it will join L, and if RQ is extended, then it will join at point M. I'll assume this side to be A. This is the radius, so I can say, in other words, this is also A. Now this value MRL is also A and A respectively. In square MN LR, the value of the diagonal comes out to be root 2 times of A. Why? Because D square is equals to A square plus A square. This will become 2A square. D will become root 2 times of A. Now I know the value of this A, that is Pn is equals to A. I need to find the value of Rp. So Rp is nothing but, now this root 2A is Rn. Rn is equals to root 2 times of A. So Rp is nothing but Rn minus Pn. So root 2 times of A minus A. This turns out to be root 2 minus 1 times of A. Now this is the value of diagonal. In other words, I can say diagonal is nothing but root 2 times of side. So side for smaller square is diagonal upon root 2. This will become root 2 minus 1 upon A upon root 2. Now the question is asking, what is the area of the square of the side MN and square of the size PQRS? Now area of square of MN LR is nothing but side square, which is A square, and area of PQRS comes out to be root 2 minus 1 times of A upon root 2 whole square. Now this value will become A square root 2 minus 1 square A square upon 2. This A square and A square get cancelled. This value will become 2 upon 2 minus 2 root 2 plus 1. This turns out to be 2 upon 3 minus 2 root 2. So our ratio comes out to be 2 is to 3 minus 2 root 2. So our answer to this question is 2 is to 3 minus 2 root 2. Let's look at the solution to this question. But that's all for this session. Stay tuned with us for more such videos. Thank you.